Welcome everyone, welcome to the stream. I want to welcome everyone in the chat, so let me know when you're here. We're waiting for some people to drop in. And let me know if you can hear me, if audio quality and video quality is good. So we are ready to start. Hi, there's AK1CA is there. Can you hear me? How are we doing with the audio? Great. Okay, so we're ready to start. Thanks for joining. So this is going to be a little bit of a chill stream, but we are going to do some stuff here on my Ender printer. I prepared lots of parts that I want to use on this printer. You've seen this printer already. It has been modified many times already. And today, like just a few weeks ago, I had to disassemble the hot end because it was clogged. Then I had to disassemble everything and check what's going on. Figured that the hot end was clogged, and then I had to take it apart. And then suddenly also the second printer broke down, and I also figured in the meanwhile that printing faster, I was reaching some of the limits of the hot end, specifically of the melting speed. And so I was deciding to go for a new hot end now, a new extruder, because the extruder itself also made some issues. I was using a very cheap BMG clone, and yeah, that was the perfect moment to try out a few more new things. HeroMe 7 came out, and I was like, okay, with so many things now, the printer is broken, new hot end, new extruder, new HeroMe, let's do this. And that's why we're here, right? So I will briefly walk you through the things that I will add to the Ender 3 V2. And the Ender 3 V2 is currently more or less disassembled. So this is the frame is still kind of here. There is, yeah, I've added these feet because we have a new blower fan. That was already there. That's covering the electronics case. So that needs a little bit more clearance. That's why we have these feet attached. And then more or less everything else has been disassembled and has been detached. So nothing that I wanted to show you in the live stream because that's rather boring. So the more exciting part is going to come when we reassemble everything with the new parts. And that's what I'm going to show you right now, so you can see what we are actually attaching to this printer. So I'm going to start with the HeroMe parts, and I think the best is to show it to you in the close-up. So this is this is the new parts here. So double check whether we can see everything. So we are starting with the HeroMe base, and this is the new HeroMe 7 base. It has all these threaded inserts now, and it has already the Ender 3 V2 backplate, which is going to be attached to the printer. So what you need to know about the HeroMe hot end system is that every printer has a specific plate for the gantry. So the gantry adapter fits to the specific printer. And this is the gantry adapter for the Ender 3 V2. And all the other parts, except this gantry adapter, are not printer specific. So this is the only printer specific thing. And this has been attached to the base with 4 screws. And then this is basically what gets attached to the gantry. And then all the other parts are going to be attached to this base from the side, from the top, from the bottom, depending what you need. Everything else is going to come afterwards. So the selection that you need to make in the first place is what printer do I have, what gantry adapter do I need, and then of course, the hot end. The old hot end is this one. This is the Creality MK8 style hot end. And if you would want to attach that to the HeroMe, you would need this kind of hot end attachment. So this is how it comes down to the printer. So this is just one part that's gonna be mounting point for the hot end. But we're not using that because I'm replacing this with the new size engineering hot end here, the Mosquito Magnum. So this is going to be the new hot end. A few words about this. This is the hot end mount for HeroMe. I printed this in ASA. Andy sent me a new version of this just today, so I printed a new one just today in ASA. This is the Magnum hot end, and there is a new nozzle here. This is the vanadium nozzle for high temperature purposes. Still have the 0.4. I'm gonna replace that at a later stage with the 0.6 or 0.8 to be even more for prototyping purposes. And then on top of that, we're gonna have this HextrudORT Extruder. It's a dual gear extruder that is 3D printed, so most parts are 3D printed. The inner parts here are from Bondtech, so there's a kit available which you can buy. It's around about 40 bucks, so it's not cheap. It's basically the inertia of a BMG extruder, but for the specific version here, this is the HextrudORT version, which has specific parts. To make this a very, very small extrusion system, I think it weighs just around 33 grams with the motor, so pretty lightweight. And on the back we have the LDO NEMA 14 pancake motor, so very lightweight setup, dual gear, adjustable pressure here on the side. And that's going to be the thing that comes last on top. You will see in a moment how this all comes together. And then the usual cooling question, always like, what do we do in terms of cooling? Are we using dual fans? Are we using a single fan setup? So there's multiple ways to do this. This is the dual fan mount, which you could use. So this is one way to do it. This is two mounts for two fans at the same time. 15 blower fans, but you can also go for separate ones. So these are basically doing the same thing. You have two separate mounts which are going to be attached to the base from each side, from left and right. These two parts actually are identical, or they will give you the same as this bigger mount, right? The only difference is that these two are separately are a little bit more lightweight, just a few grams in weight saved. This could come in handy if you want to attach some LED lights, because there is a little bar here that connects these two, and then you can have a little LED strip right here lighting up the hot end. So that could be one thing, but there's also LED mounts now and probe mounts where you could attach a camera to the hot end just to have a close-up look. So there's different possibilities to do the same thing. Last but not least, we have filament sensor that was already on the printer, and we also have the Beer Touch, where we need to find in the end the right mount, because the mounts for the Beer Touch are dependent on the cooling setup that you're using and the distance that you want and the orientation that you want. So finding the right Beer Touch or probe mount can be a little bit of a challenge. But luckily they are very small, so you can print multiple versions and then try out a few more. I think I printed a few things just to have some to try out, and if those even don't fit, I probably can print a new one in a matter of a few minutes. That's it. The rest is standard parts like these fans. They have been already on this printer. This is the blower fan for the hot end that has already been there. That's going to be attached here on the front of the base. You can also use the existing, like if you have an Ender printer, you can just reuse the old fan that was there already, so no need to change it out. This is just a more powerful and more silent fan, but turns out that this whole setup can become quite loud if these blower fans are going full speed. There's probably not that much of a gain if you're using the silent fan. That's not going to help so much. But anyways, it's a high quality fan. Good. So far, I think I went through all the things that we're going to use today in this mount. Any questions so far in the chat? I think we have 23 people already in the stream. I want to welcome everyone. Let me know where you're coming from. New faces, a few more faces showed up. Hello, Mark D. I think you've been there last time, I remember. Michael, Ryan, Audium, Catmiral 3D, Mark, William, Martin Harris, and Engine Aras. So welcome everyone. Let me know where you're coming from. There's so many countries always joining, like from all over the place. I'm located in Germany, and I'm always curious to know who's joining from which part of the world, just to get some impression, like what are people up for? What is the time zone? UK based, okay, Denmark. Yeah, oh yeah, it's Austria, so not so far from here actually. Michael Ryan is from Chicago. I think it's pretty, that's more like in the afternoon, right? Frank is from Berlin. I think you've been there last time, I remember. UK, Midwest, yes. Mentioning the UK, I was asking on Twitter who's coming to the Sanjay Mortimer Rep Festival in December, because I know that's pretty far out, right? No one's thinking about that at the moment. I'm like, it's not already spring even fully, and I'm already planning for my visit in Oxford in December. So I've already booked the flight, booked the hotel. I will be there. I'm not going to be in any other Rep festival this year, but I planned for the one in the UK in December. So if you're there, let me know. I'm happy to meet anyone. So that's going to be fun. D8-3D then is 2 hours south of Michael in Illinois. Okay, nice. Yeah, so that's actually gonna be my first Rep festival. I've never went to one, and I was happy to see that we have now one in Europe. I'm not saying that I don't want to come to the US, but it's of course it's much more expensive for me and more travel, and this year is a little tight, I would say, from a financial point of view. So I don't have yet the budget to come. Maybe next year. I hope so, at least, that there's going to be a little bit more space or budget for me to come to visit at least one of the reps in maybe the Midwest or whatever that might be, the best chance, or the East Coast. So yeah, so I would say with that, keep on posting in the chat, keep discussing. I'm going to look at the chat from time to time. I'm not going to look at the chat all the time because I will be super busy now to assemble everything. I'm trying to give you the best, do the best in terms of telling you what I am doing. And let me just adjust a few little things here. So we have the screen right. Okay, so my first thing that I want to do here is get a little bit organized in terms of the cable work. I have a few things that I'm not going to change actually. So the filament sensor, obviously, and the blower fans, this is going to stay as this is. So we're going to push this a little bit away. We're also putting away the old hot end because we're not using it. So let me just put it somewhere. The studio is unfortunately at the moment quite messy because I've told you that we had this new studio in the city and moved in last year, actually a little more than 1 year back. And I moved back into my basement now because it was just so much easier for me just to be closer to home and to be able to go down here, watch my printers, then do some recording, tinker around with things. I was like finding out after the fact that it's just so much easier for me, which is a pity. I love the new studio, but it's yeah, it's currently I'm just here, and probably we're not gonna stay in the studio. But anyways, let's start. So I think I will just put the printer upright again, just to have like, because what I want to do, of course, before I do final assembly, I want to check some of the electronics. So probably like maybe let's first attach some of the remaining cables. It's probably clever. So I will try to tell you what I'm doing. I cannot show you everything all the time. I will show you quickly what I'm doing here at the back. Hopefully, why is this not working now? It was working. It's always the same every time I'm trying to use my mobile phone. It's really struggling. Oh my goodness. It's not working. Yeah, I have to figure that out at some point. So first thing here that I want to show you is the assembly of the hot end. And then we're gonna attach all the rest of the cables. So this is, as I told you, this is the base, the HeroMe base and the Gantry adapter for the Ender 3v2. So the first thing that I need to attach here to the base is the hot end. The hot end is already like attached with 2 screws to this hot end mount, and that goes in here. So it's just inserted from the top, and you can really see that this is how the placement will be. What I didn't get yet is still on the way is the sock for the Magnum hot end. So I want to attach the silicone sock. Probably not a problem at the moment. For now, we'll just maybe do some test print, but that's it. So the hot end mount comes in from the top, and then this extruder motor is coming as a last thing. It's going to be screwed in from the top. So what I need to do now is I need to figure out how long the PTFE tube is going to be that we are going to use to connect all of the parts. So because what we want is a PTFE tube that goes into this hot end, and it might be that I have to drill this hole bigger because it might be too tight. Yeah, that can absolutely be that we have to do that now. Didn't test that before, but we have to put the PTFE tube in here. So it's gonna be going down to the hot end. Same on the other side, we have to put it through here and put it into the extruder. And then we need to figure the right length, so we have connected both parts with the PTFE tube. Just push them together, right? So there's no gap, but there's also no slack. So I don't want, like, I want the PTFE to be at exactly the length that is required to have a tight connection. So there's no gap when the filament moves up and down, right? So this is how it goes in. If this doesn't go through here, I have to drill this hole a tiny bit larger. Seems that this, at least this PTFE tube seems to be quite thick. We can also check if a thinner one has, if I got one left. There might be one in my drawer. Let me see. still got some Capricorn PTFE left over. And while I'm taking this out, I will look at the chat. So, yeah, nobody has extra money. That's the point. That's also my reason why I'm not traveling so much this year, actually. So is this PTFE tube thinner? No, it's not actually, but I think I'm gonna go with the Capricorn. So I will take a drill and make that larger. Let's look at the chat, what's going on. So 1066 is going for the SMRF. That's great, so maybe we can meet there. I'll be around. Maybe Andy Soderberg is also there. He's the creator of the Hero Me. I think he's gonna join our chat session in maybe 20 minutes or so, if he has the chance. Andy is currently at, I think he's at is it Midwest or is it, well, there's currently a rap festival going on. I have forgotten where it is exactly, but there is one going this weekend and he is currently there. So if you want to meet him, that's the chance. But he told me that he's maybe coming to the UK in December. Do not remove this stream. Lots of good info, JW200. Like, I'm not removing any of my streams unless they're very old and not helpful anymore. And some of you did the ANIT printers. I still have it here. My ANIT printer is still alive. I didn't turn it on since a few years. We're definitely going to turn the ANIT A8 on in one of the next live streams. I've said that already, but I have this broken printer. I need to fix it. So, because I still have a project going on where I need at least this printer to be working, let me do the following. I will fetch my drill and I'm gonna get the proper drill bit from the workshop so I can fix the PTFE inlet. So let's get some drill bits here. Be back in a second. So I have no camera that I can take with me while I'm getting this stuff, but I'm still here. Good. So now, I think the thing that we're going to do, disassemble this quickly. The disassembly of these parts is quite easy because you have, in this case, you have just two screws that you need to detach, or you need a smaller one. Actually, this is too big. So the slice hot end, maybe I need the hex driver for this. So let me show this to you. The way how it is done. So here we go. This is the attachment of the hot end and the mount. It can be detached easily just using the hex driver. There's two screws from the top. I'm just gonna loosen them up so we can get it detached. So this is everything that we need to do, and this hole here for the PTFE tube coming in is a little bit too small, so we're just gonna use a drill to make it a little larger. How much do we need? Not so sure actually. This is perfect. So what is this? I can't read it. This is a 4.5 drill bit, okay. So let's make this a little larger. Oh, not easy. Okay, that should be fine. That should be working. Yeah, that's perfect. That's perfect. So I don't want this to be, yeah, to be stuck in any way, because like the part that's going to hold the PTFE tube in place is the extruder, where it perfectly fits, and we don't need too much of a, yeah, hard connection here, or how would you say, too much resistance. Should be working, and it can be easily detached. So let's reassemble this. Just let me figure the right orientation. Yeah, this is facing forward and putting in the screws again. So, Michael Ryan, what was it? RMMF, what's that? RMRRF, oh my goodness. So, where is it? Like, where does it take place? I have no idea where this is. Rocky Mountain rep. Okay, Rocky Mountain rep. Interesting. What's the next city where this is taking place? Remedy. Hey, welcome to the stream. So I've reattached this thing. So we're now ready. So we're gonna start with this PTFE tube coming into the extruder, pushing it all the way in. Or let's use the Capricorn just for the sake of quality. So here we go. We push it in, and then we're gonna figure out how much we need, just roughly, and then I'm gonna cut it a little one by one, just marking it with my knife. So let's first make a cut. Just leave a little bit of space. Let me see how much we want. So this goes in until this point. So really just ends here on top. So what I would do now is just cut it a little longer. Or we can just mark it right here. Where's my knife here? But I'm not going to cut it with the knife. I'm going to cut it with my special cutting tool. So let's get as close as possible to figure the length. So hold everything in place, figure where this is going to end, and then it should be right above here. So we can always remove a bit, but I think it's actually has a little bit of a cavity. So this should be perfect. So you can see it now, and I'm using my cutting tool to make a nice and flat cut. So this looks great. And now these two parts come together. So we're going to push in. And here, so it's ending. So it's not yet completely connected. So only thing that I don't want anything pushing up. But this looks good. I think it's like when it ends right here, that's perfect because that's the surface of the extruder. So there is no space anymore. Should be good. And that's how it comes together. So going back, we're gonna attach this hot end now to the base. Step 1. Step 2, the extruder motor comes on top, and then we're using our 2 screws here to attach it, to fix it down. Just need the right screwdriver. This should be the right one. So far so good. That's pretty close. Not much clearance here for this screw here from the HextrudORT, but still we can do it. Should be fine. And we're gonna fix it down as much as we can. Tighten that up. So there shouldn't be any gaps between these parts anymore. So also here, this should be pushing down on the base. Same here. That looks good so far. Probably tightening up this side a bit more, but I think we're good. So that's it for the assembly, and like this, we can put it on the scale how much that weighs. But that's pretty lightweight still. So this whole thing currently is how much? Let's find out. Let's find out. So, it's my scale. Yeah, the camera is not happy. I'll probably have to fix one thing now, because it's... Yeah, go ahead. I think that's better. So, how much is it? $234 grams. Yeah, that's, I feel still, the whole unit feels not too heavy. And the most heavy thing is probably the hot end now and the motor. So these two things are quite equally, yeah, like pretty much in balance now. A few more things are coming, like the fans are coming, Beal touch, but overall, yeah, this is a pretty powerful thing now because the motor, the gear drive is pretty powerful, has a nice dual gear setup. And this is going to be the solution that I need for printing at higher temperature and also faster. It's gonna melt the filament much better. So let's continue. From here, just a few more things that we need to attach. And probably a few things what we will do now is not going to do this on the table, but instead we are putting it on the printer because the Gantry adapter has specific mounting points, right? And we could have done all of this also later. I mean, if I figure that this is too complicated now to attach it to the Gantry, we can always like remove it quickly and then do it again on the printer. But we have one mounting point here on this side with a small hole where we need to insert a little screw. So probably yeah, we'll see if this works out. If not, gonna just put it off again. And then on the other side, we also have one screw that we can use here. That's gonna go into the other side of the Gantry. And unfortunately, my Ender 3 doesn't have the third hole, which is missing because my Ender 3 V2 was one of the most, like probably one of the first ones that came out of production, and the later ones have another hole here that I cannot use at the moment. So I probably have to drill that at some day to make it, like to make another hole and to have a thread. I'm just missing the right tools for that. So, what's going on with the chat? The Bob is here. I think you've been here also last time. Pokey Low, oh my goodness, Pokey Low Lav B4 What's your opinion about the Bambu Lab X1 Carbon with AMS? Well, I think it's a great printer. Don't want to talk about it too much because we have plenty of chances very soon. I have to repair my Bambu at the moment because my X1 Carbon is now over 10 months old. I've been using it pretty much every single day, maybe with some exceptions, but like it was in use most of the time, I would say. And it was manufactured before the Kickstarter campaign. And the reason that it's not working at the moment is that like just a simple thing like a thermistor broke, things that happen. This happened to other printers that I had also. The problem now is that I bought new thermistors and they don't fit on, like they don't fit on the PCB plugs. And the reason for that is because Bambu changed in the actual production units, they changed the type of plugs they use for all of the electronics that they attach to the hot end. So all like the thermistor connector, the heater, and all the plugs have been changed after these first units. And now the replacement parts that you can buy from the store don't fit it anymore. So I now got new PCB boards. New parts. Like I have to replace everything now to get a official stock hot end on this printer again. From there on, I can use the official spare parts. That's where I am. So I didn't get to repair it yet, but I will have to do it very soon because I need that printer to be working. Because it's like I was lucky to get the KD printer, the KD X+3. I've just, like, actually this part here has been printed, or this hot end mount here has been printed on the KD today in 20 minutes. Pretty fast. That's also a Core XY printer. It works pretty well. Like it works just as out of the box. It does high quality fast prints. In terms of like speed, it's absolutely comparable to the X1. Doesn't have multicolor, doesn't have a lot of other things. It's much more bare bone, but it's also more affordable, and for most of the purposes, it's probably the right printer. In some regards, maybe easier to fix. So the Bob. Maybe I have missed that part in the beginning. Have you printed the parts on your own before and placed the inlays on your own? Yes, I've printed these parts on my own. I also reached out to Andy because like we were talking just the other day about like what is the future for this, and we will have an interview next week. It's not going to be live, but we're doing it, recording it, and then we're going to premiere that interview, so you can join in the chat and we can discuss with Andy. The thing is that he wants to offer pre-printed, and there's already shops that offer these parts pre-printed and where all the hot end where the threads are inserted already. And he's looking for like expanding that. And there's also a pro version coming, which is going to be different in some ways for like different purposes, and like bigger hot ends which don't fit in the standard Hirumi at the moment. So we were talking about that. We will talk about it in the interview even more, and yeah, that's where we are at the moment. Thank you, Pokey Low Lav B4 for 5 Polish. I think is Polish money, PLN, if I'm not wrong. Thank you. No idea how much that is. PLN 5, like 5 PLN. What is that? Thank you anyways. Thank you anyways. Remedy. Think here's the Ender 3, somewhat modded and recently installed Clipper, and now I have some printing issues. All that. This is so sad to hear that. I didn't make the jump to Clipper yet. I think I will do at some point. Like we'll try it out. The problem is that like I need my printers working, so I will probably do it on a printer that I'm not using so much at the moment. Maybe one of the Sovol printers, like this one here. Like I have, oh my goodness, my workshop is so messy at the moment. So I have the Sovol SB06 here that didn't yet fully utilize for any projects except the testing that I'm doing. So I'm currently testing the printer, doing prints, having some issues, just to be honest. I printed a few things that failed, at least one thing that failed now because the hot end is a little bit of a troublemaker in some specific ways that I will cover in my review. And then we have the SV06 Plus here, which is basically having the same hot end but with a larger melting zone. And just today I got a new part in, which is a replacement. Andy from the HeroMe project, he was already giving me a base plate, so a Gantry adapter for the SV06, so we will be able to mod the hot end now. Because one of the issues that this hot end has that I'm trying to fix with a new extruder, or at least modifying it, is that it grinds a lot the filament, right? So it's grinding, at least that's my experience. If you have lots of retractions going on, it grinds the filament, starting to eat the filament. And if you have too many retractions in a short period, it's just gonna be stuck, but it's not gonna clog. It's just not transporting the filament anymore because the filament is like thin. So it's getting quite thin, and then at some point it doesn't doesn't touch the gears anymore, and it doesn't help to increase the pressure, right? So it's not solvable in that regard. I tried it, but it's not working. That's one of the issues that I had with this printer so far, and just trying to figure out if that is solvable using firmware, or if it's solvable using if you have to do mechanical changes, so to say. So let's continue, because I want to get this thing going. I really want to get going. What hot end would you recommend for higher temperature? Well, absolutely something that is all metal. You can modify Creality hot ends. This hot end that I had here, that I had on this printer before. So I just want to tell you this. What is this? Why I'm swapping this out? It's not because it's not capable of doing high temperature. This hot end is already modified. So it has a new thread, or has a throat in here. It has been replaced. So this part here that connects the cooling block and the heating block, right, where the filament goes in. This is a new part that's all metal. And previously, so the old hot end throat, I think Creality is now doing it differently. At least in the better printer versions, they have an all metal hot end now. And that means there is no PTFE tube in here anymore. Before, we had a PTFE tube in the middle here, which went really down to the nozzle, to the very end here, touching the nozzle, and that meant if you're printing higher than 235-ish, you're gonna start melting and destroying the PTFE tube, and that's what's already fixed here. So you could, in theory, print at much higher temperature with this modified hot end. Of course, you will probably want to change out the nozzle, but like you can modify your existing Creality hot end just with replacing this part. I made a video about that. If you're interested, you can check it out. It's mentioned in, I think, at least in the last HeroMe upgrade that I did. I mentioned already how I did this, and there is also other videos about this out there, right? I think Chuck from the Chap channel, he always does this to his hot ends. That's where I got it from. So he has several videos where he's also talking about it. So this could be done. So like high temperature, you don't have to do like a complete swap out. You don't have to replace everything, but you can also like get something like the Mosquito hot end. Of course, that is the more expensive option, right? Because this hot end I think all the like this is not. I mean, this you couldn't call this an Ender 3 anymore. And honestly, this is not. It's not really an Ender 3 anymore. It is something else. And the only thing that is left from the Ender 3, you could say, is the main board, which is probably also going to be swapped out at some point. For like, I want to go dual Z-axis, but with 2 stepper motors, separate ones, so we can do like proper Z leveling, auto Z leveling, not auto bed leveling, but auto Z leveling with 2 separate motors. And then that's why we need a different mainboard, because there is just 1 stepper motor more that you, stepper motor more and 1 stepper driver more that you need for this, and this board just has 4, right? So it doesn't work. That's what's going to happen at some point. So I have 2 more things here. The thermistor from Slice Engineering that I'm going to just plug into the main board. I have attached this little plug here. That's a GST connector, standard thing, pretty much. But it doesn't come with the connector, so I had to do it myself. And this is the new heating cartridge. That's also more powerful for higher temperatures. Clearly thicker, a little bit thicker than the original one from the Ender 3. That's why I couldn't use it. So we have these 2 things that we now attach to the main board first. So we have the cables already coming out at the right point. So Michael went into 3D printing a year ago and got his printer, sorry, for $100. Well, that's a pretty good deal, I would say. Pretty good deal. High temperature hot ends, Hiromi Gen 6. Yeah, that's great. I mean, this is the upgrades that probably at some point most of us will do to the Ender printers, because like, I like the Ender 3s and the Ender, like the Ender, I think the best printer is probably the Ender 3 Pro, not even the Ender 3 V2. You might argue, but the most painful thing on the Ender 3 V2 is probably the display, because it's not, by default, it's not so much supported by Marlin firmware, but you can, like with any firmware, you will have to, I would change out this display for a standard wrap style display. It's just so much easier. And I don't need a touch screen or anything. Honestly, I don't need it. Yeah, so what are you going to run Marlin on this printer? Yes. Marlin firmware is on this printer at the moment. It is already a custom firmware because of the changes that I've done so far. And I will probably have to, we'll see, right? I will check out what I have to change. Probably not so much. The stepper driver probably requires a different setting in terms of maybe the direction is inverted. I have no idea at the moment. We can also change that in the firmware. Then we can probably have to do different steps for the, like probably the steps are different for this combination here for this gear set. But probably, hopefully, we can use the existing Marlin firmware that's on this printer. If not, I can always go to the firmware factory and just make 1-2 changes, build a new one, and then try that. That's easy. What's the advantage? Remedy asks, what's the advantage of the new heating cartridge? Well, honestly, the heating cartridge isn't that much of a big deal, but it's just like perfectly fits this hot end, right? So that's the major reason why I'm using it, because it fits in here perfectly. The one from the Ender 3 is a bit shorter, and I think the diameter is not perfect. Like, it will probably work if you use some thermal paste, which we also are going to use here. But that's the only, and it's a little more powerful. I think it has 50 watt. And if I'm not wrong, the Ender heating cartridge is 35, 40 watt. So it's probably like for the higher temperatures, it's more powerful, and that could be advantage in that point. The other thing, the thermistor, why is that different, or why I'm using the one? Default thermistors don't go up to 300 degrees. So you cannot measure that, honestly. So at some point, they're just gonna read the same value, so topping out at some point. Maybe you also could destroy them if you go higher, and that's why Slice Engineering sells a specific thermistor, and that wasn't available for quite a while now, so it is just available again. And honestly, you don't find these kind of high temperature thermistors on the market just on anywhere. There might be some now, but there was a shortage of these kind of parts for a while, and I wanted to use the proper one so I can really try out going to the limit. So if you're not intending to do that, you can also continue using. But the other problem is, at least with this kind of hot end, is that the original thermistor it just looks so much different. It's a very small glass tip, so very small sensor that's inserted in the old hot end, and this one is a metallic. Yeah, it's wrapped inside of a little tube. I don't know if you can see that. Hard to see, probably. Hard to get in focus, at least. Let's try. Here we go. So there's a little metal tube now, and that's going to be inserted into the hot end. The Ender one isn't looking like this. This is just a little tip with a glass sensor tip. And yeah, it has just had more surface area, and probably is gonna read the higher temperatures better. But yeah, anyways, this is why it's different. Let's go back to this here. I want to fix these parts now. I want to attach the cables so we can flip the printer. I'm not gonna do a table flip. But a printer flip. So attaching the cable, there is one plug here on the main board, simply putting that in, plugging that in, everything that we have to do. So that's the thermistor. The motor is already attached and plugged in. And at some point we will have to reorganize the wiring. So I have this flexible cable tube here. I like this one specifically because it's not closed, so you don't have to push all the cables through the middle, which is quite painful, honestly. But we can just open it up like this, right? So it's closing by itself, and we can just push in new cable. And we can also reinsert some cables later quite easily because it's closing like this. I like these a lot. So the last cable that we need is the heater cartridge. And on the Creality mainboards, this is just 2 screws or a terminal block that we have to attach that to. It's also quite simple. So I need a bit more light. Honestly, it's very dark on this side. Where is my tube light? Here we go. Let's see if that works. Okay. So this should be helping at least to find the terminal block. Any questions so far? Thoughts on thermal paste? Well, we have it here. Thermal paste. Honestly, there's different thermal paste. There's a lot of different thermal paste available. And you have to look for the right one for higher temperatures. This I searched for a while and found this here, which is EC360 Ruby, which is supposed to be the best one and the most expensive one, of course. Again, everything that has some value is also super expensive in the end. But yeah, normal thermal, like if you, for example, were to go to use some thermal paste that you have on your computer fan or on your computer CPU, right? These are not made for 3D printers. So if you have some and you think you can use it, I would hardly discourage you from doing that, because thermal paste that's for CPUs is like probably made for 100 degrees something, but not for 300 degrees, and it's not going to be lasting long. Actually could just go up in, yeah, not in flames, but it's just going to be like fuming away, and then you have nothing anymore. So I have to get these cables in. And this is a very tiny spot. And I'm just too lazy to take the mainboard out, honestly. I don't want to do it just for inserting these two cables. Oh my goodness. This is why we cannot have nice things, because we cannot have plugs. We have to use terminal blocks. Oh my goodness, Creality, why do we need to do that? Oh my goodness. Come on. The hard part here is to find the right point of insertion for this cable. If you're not seeing it, it's twice as hard. And it's always the same story. You think you have it inserted correctly, and then you tighten up the screw, and then it's not grabbing the cable. Terrible. Here we go. I think I got it. One cable fixed. Second one is coming now. So, and then we'll go quickly through the cables. Is it in the right spot now or not? No, this is so terrible, honestly. I'm wondering if there is a Vago terminal block, if you know what I mean. I like these Vago cable clips where you just put in the cable, you turn up the lever, put in the cable, turn the lever down, and the cable is fixed, right? That is so easy. Why can we not have that on 3D printers? Good. The Bob, thank you. Oh my goodness, second donation today. Actually, I rarely get donations on my streams, so I'm really surprised sometimes. I always also miss them. I have to watch the chat a little more. Thoughts on thermal paste? We had that already. if you would switch to Clipper, you could run the hot end with a CAN bus and use the original mainland. Well, yeah, that's interesting to hear. I think I have to look it up, like I have to get into it. It sounds so interesting, and probably we can print even faster than with Marlin. Let's see. Now when it's black and orange part, it looks like a Prusa. Well, yeah, that's the point. I've had so much Prusament orange. It's actually Prusament, right? It's not only orange, but it's really Prusament orange. I had a lot of that left over from another project, and that's why I just said, hey, let's use it here. Let's go for Prusament orange. So I think all of the cables are now attached to the main board. And actually, I only changed out the thermistor cable and the heater cable. Everything else is still the same. This one is a little stiff for a little bit too stiff actually. So let's just bring those cables out here on the side. So we have at least everything somewhat organized. We will do proper cable management in a bit. I'll just briefly close this to have this is the wrong direction. So we're briefly closing this so we have more space to work with. We have clearance again on the bottom, so I'm not doing lots of cleanup here. So we'll do this again when we figure that the printer is working. So I have to turn it on the other side now, so that's why I need a little more organization here. So at least this cooling solution is in place and attached. Where is the original screw? Here we go. Yeah, I'm gonna fix some of the cables now, temporarily at least, so we can focus on the hot end build for now, and then at the very end, maybe not even in the live stream, because I think that's just nice to have, and very boring is the cable cleanup, where we wrap this cable, all these cables in the shrink wrap, or in this nicer cable wrap. So I'm gonna save that for the very last. So, because we want to get going, right? At least we want to test out if things work. So that's gonna do it for now. So let's keep things as they are. Just want to not mess up too much here. So next thing to do, and we probably want to bring in our camera a bit closer. That's going to help to see what's going on. Here we go. So we are coming in from the side. Here is the gantry. So it's probably we still have to turn around. No, we're actually in the right direction. So this is the front side. So from here on we'll see what's going on. So the idea now is actually let me think about it. I think I have to just I've swapped out these wheels to figure, like, because they were completely messed up. After a few thousand hours of printing, I've changed these the rubber wheels, but probably just have to turn this around. I think I've attached it in the wrong direction. I was just testing out the new wheels, but that's an easy fix. Didn't think about it when I attached it. Just wanted to see it working, but that's easy. So the gantry can, thing is, probably you can also attach the gantry to the here on me first, but I want to do it on the printer because then we have some point where everything is fixed, makes it a little easier to work with. And he has a nice, he calls that the workbench. So he has the Here on Me workbench. And that's basically it's just an attachment where you can put the whole Here on Me hot end and assemble it and then work with it. So it has a mount point like on the printer. I don't have that at the moment. I didn't print it out. So we're just going to use the printer frame as our workbench. So here we go. One thing to mention is that these rubber wheels on any 3D printer that has the V-rail system like this, like the Enders and so many other printers, these rubber wheels will wear down over time, right? So the rubber will just become yeah, it's gonna like grind into the frame just because of the pressure, and then at some point you will see that this whole thing starts wobbling. And you can, of course, you can increase the pressure for quite a bit until there's probably no rubber left anymore. I mean, there's also limits to that because the attachment or the tightening knob here, or the I think it's a tightening wheel here. There is limits how much that can be tightened after these rubber wheels wear out. And I think that's like at some point you will see that you cannot fix it anymore. And then you have to swap these wheels out. So I don't want to make it too much here. So there's a point where it starts wobbling. Then we just want to go beyond that. We still have it running quite easily. That's good. The belts come in. From the side. That's it. And if it's not working, we can also decrease the tension a bit. Good. I want to check the belt tension. So now the gantry adapter goes over here. That's how it's going to be mounted. And I will see whether I can still use still come in here with a little screw, or if I have to detach the top. But I already see that this is going to be difficult, because if you can see it here, where is the point here? No, this is the point. We have to come in with a little screw here on the side. It's gonna be a challenge. So why not make life easier? Just take this off one more time, just quickly. It's gonna be a thing of just 10 seconds or so. And put that away, and then we can attach it more easily. How does it work? There's one screw coming in from the back. Here at the upper left corner, so to say. Holding this thing in place. So here is one screw coming in from the back side. And then another one here. And there is a special clip for the Ender 3. Just have to find it. Here it is. There's a little clip. That little clip comes from the back side. And there's also a little threaded insert here. And that clip holds the gantry in place here. The problem with, like, I'm missing this last hole here. This is actually missing on my gantry. Probably can drill it in, but I also have to make a little thread then. That's what I'm missing. Still, it's going to be fine. Still going to be attached well enough, even though there is no third screw here. So just inserting this one. So the clip is in place and it's holding the gantry adapter quite well. I think we're still wobbling a bit. So still have to tighten this knot just a tiny bit more. Oh, that's worse in this direction, actually. So just want to be super careful with tightening up this nut here, because if you do too much, then you're pressing the rubber wheels too much against the rail, and then these are going to wear out even faster, and you will see a lot of rubber coming off and then laying down on this rail system here. It's going to be super dirty very soon. Okay, spamming caps, what is that? Why the Mosquito and another hot end? Yeah, why do we do that? My personal reason for that is I want to print at higher temperatures with this hot end, and I want to print a little faster. So we'll have a little more power to melt the filament. It's going to have a little more time. It's the Magnum version, so it has more capacity heating up. So the filament has a little more time to travel through and heat up until it reaches the nozzle tip, so we can go higher speed, and the filament has more time to melt. So we can print a little bit faster with this. We cannot print like crazy fast, like with a Magnum hot end that is much longer. So something like the E3D, how's it called? It's not called Magnum, but it's like a much longer one. And that allows even faster printing. I think this is a good balance. What I also didn't want, I didn't want to extend the hot end. So I didn't want it to be longer, because then you're losing printing height, right? So if this comes down even further by having a longer heat block, you're losing exactly that amount of printing height and printing volume. In my case, I have some projects where I really need to go to like almost the upper limit of this printer. So the only solution for me would be to get a bigger printer, or to stay within the limits of what we normally have here in terms of the hot end height, right? But yeah, this slice engineering hot end, it can go print at higher temperatures, 300 degrees. It has more volume of the heating block, so it can also hold the temperature longer with less effort, so to say. There's a few things that I like about it. But honestly, you don't have to do that, right? So you can just use your existing ender hot end and keep using that. And the extruder is also different. Hopefully gonna be a little bit more powerful. Andy is here. Welcome. If you see some of your messages deleted, by the way, there's maybe some reasons. There's, first of all, posting links is not allowed. Spamming is not allowed. We have Nightbot taking care of the problems. If people start spamming or posting links here without telling me, then they're gonna be deleted from the chat, because we don't want anyone to post harmful links or spam the chat. Stop spamming caps. Yeah, stop spamming caps. That means using caps for all of the words that you're writing is not allowed, because yeah, because of reasons. Right now, I don't like it, and there's no reason to use caps. Like, if people write messages with all caps on, I don't get it. I don't understand why people are doing that. So please don't use caps. Okay. Good. So our gantry adapter with the clip here and the screws on the left-hand side are attached. One screw missing for reasons. We have fixed the hot end and also the extruder from the top now. And we're gonna start assembling the rest of the pieces, bringing a lot of the cables in place. So one thing, for example, is the cooling fans for the hot end cooling, or the part cooling fans. Let me just orient this correctly. So this is the left-hand side blower. So what I'm going to do first is I'm gonna mount it, because the way how it works, and that's what surprised me a little, or I wasn't understanding that correctly, but if you insert the fan now and put in the screws, because you think, yeah, it's easy to just go and assemble that now and then attach it, that doesn't work, because then you're not reaching the second attachment screw anymore. So you have to attach it first and then put in the fan and then attach the fan. So let's do that. Probably gonna use some shorter screws now. These are a little too long. Let's see if M36 is enough. Oh, that's a little too short. 8mm will probably work. Good. Yeah, you can ask Andy how he's doing in Colorado at the Rep Festival. Probably having some fun there. And I'm good old Germany, which is pretty cold at the moment. So, yeah, Andy, I've got some feedback for you. This hole here, where I want to bring in my screwdriver to attach my blower mount, the hole isn't big enough for my screwdriver. So maybe you can make the slot just a little bit larger so I can bring my screwdriver through. That would be awesome, because honestly, I hate using hex drivers. I can't come through here. So we're back to hex drivers, I guess. Honestly, I have to... Yeah, there's a few ones here in the printer. I really hate hex drivers. If I can avoid it, I'm not using them. I'm always using hex screwdrivers or hex wrenches, to be more precise. I hate these L wrenches because they are mostly very painful to use, and you always take a long time if you want to attach a long screw versus just using something like a screwdriver, a proper one. It's always easier. So the height adjustment of this is also important. So we want to like have it being lowered. So let's see how much we want it, how much closer we need to go down, or how much more. So I want to have it very much just above the nozzle tip. I don't want to bring it down too much, but just having it a little more down. Of course, you don't want to have it too close to the printing surface, because then it might touch things that stick up if you have prints that have parts sticking up, and this is gonna scratch over. But I think I'm low enough, so I want to have a little bit of clearance there, not too much going down. Yeah. I use a hex key here. This is like user wrenches, but I don't like to do that. My screwdrivers here, the Vera ones, are a little thicker. The shaft is a little thicker because the advantage of these are that you can come in from an angle, so you don't have to be perpendicular. You can pretty much screw the same from all these kind of angles. You can use this. This is what I like so much about them. Don't want to miss them. Like, honestly, this is the most important thing. If you have a 3D printer, get some proper hex screwdrivers, because you are gonna be so much happier. Really, it makes your life so much easier. I mean, there is handles for these wrenches. You can print some kind of a holder or a handle adapter where you can like use it like a screwdriver, but still, then it's still a normal hex wrench. But the proper screwdrivers, they can be used. It's so much easier. Love them so much. Could even come in from here. So, other side. Let's do both sides first. There is the focus point, totally off. Will it be too heavy to use stock Ender 5 Pro motor? Andy can probably answer that, but I have an opinion also. I think that this was actually one of the decisions I made even on the first iteration of this build. I was already using a pancake stepper driver, a stepper motor, because it is just slimmer and lightweight. So I can highly recommend to get some lightweight stepper motor, but it's not a must-have. Like you can still use I think you can go with the original one and be happy with that, but personally I think the lightweight motors give you some opportunity also to mount them on the back. That's one thing I did on my first iteration. I put the motor on the back side, right? And most direct drive systems, that's gonna be an issue because these larger motors gonna run into the frame, right? So you have not clearance here anymore. Here we have lots of clearance, and with the pancake motor you have still a little bit of clearance here on the back, so the motor can be mounted on the back. So we have a little counterweight to having all the parts in the front. And if you use the original motor, this won't be possible anymore. The motor will also be facing forward, and the bigger ones, and that's gonna cause this to be even heavier, of like front heavy, which it's probably not gonna be a super critical problem, but I think it's better if it's a little more balanced. So we have the second blower attachment fixed. So now we can think about two things. Like of course we can attach the fans now into the mount. So just bringing them like in like this. So there's 1, 2, that's done. That's easy, right? So we just need a few more screws here to fix it. One thing to do. The other thing is, like, how long do these need to be? Not too long. My question here again, probably want to use So let's try this first with the long one, and then I have some special have some nuts here that are, how they're gonna called. They have it's a self-fixing or self-locking nuts. On that side here, specifically here, or on the inner, while we are closer to the base, we have to use it like this. So we have the lock nut, hold it in place, and then come here with the screw and attach it. Doesn't work the other way around, at least, because you cannot come in with the screwdriver from the inner side, right? There's no space here. We would have to, like if I would do it in a different order, fixing that first and then coming with the hot end, that would work, but I'm fine doing it this way. Second one in place. Andy has probably a different opinion. He probably says, now you can do it first, do the hot end fans and then do the extruder. Might be. Yeah. Oh, I see. Chat is going fast now. The Bondtech reverse kit stock in the free extruder was one of the first supported. Yeah, Andy is answering a lot of questions, I see, so I can continue with my build now. Good, so first two screws are in place. Now we're gonna have two more coming. So, need two more lock nuts. I only have one. Why? Well, one got lost in space. So why am I using lock nuts here? It's just for the reason that I don't want to have any nuts falling on the print bed, just in case one of them gets loose over time because of printer vibrations, that falls down. That's really a worst case for me. This is a fan that I already modified for the other build. I just cut off the mount point here, so I cannot fix it with the screw, but it's still okay. That's probably why we only have 3 knock nuts. Because for the other build I didn't have the space. I think that was on the BL Touch side, and that was just too much. Anyways, so cable management is going to be super interesting later. Okay, so we have this attached. We can also go now with the front fan. Let's just untangle the wires a bit. Okay, so front fan coming. Have that in place. I think I'm gonna need my fan protector. This is a part that is optional, so you don't have to use that. I'm using it because I think it looks great. That's the only reason. Sometimes I think it's also helpful that it holds back some of the like dust particles, or at least some bigger things from going into the fan. So it's not completely useless. And there's different designs, so you can choose your favorite, but otherwise it's still optional. But I think it's like at least could be helpful. Good. So hopefully my screws aren't too long, but I think it's good. Just the right length. So front fan is done. You can also use the Ender 3 default fan, so there's no need to change out the fan for this kind of thing. So I'm using a Noctua fan. It's the problem with that fan is that it is originally a 12-volt fan, and the printer comes with 24 volt. So you have to use a buck converter. Not the nicest solution, and in the meanwhile I got a smaller one, so I probably will swap that out for a very tiny one. Maybe move it down the line, not having it here so close to the motor. Just want to have it probably stored in the electronics box. So this was a kind of a quick fix, not the nicest thing, but yeah, it works, and it's not very heavy in that regard. So one last thing that I need to check, which was kind of a thing that I couldn't check before, or I couldn't make sure that I print out the right mount for the BL Touch, right? So the BL Touch will come in here. It will be mounted on this side. What? Something fell. It's a filament sensor. So the BL Touch should be coming right here, so it should be attached on this side. So I was thinking, like, where do I want to have it? Like, do I want to have it behind the fan, or do I want to have it just sticking out to the side? I think I'm fine with having it right here on the side, somewhere right here. So we're gonna find a good position in a moment. Just need to double check which mount I want to use. There are different mounts available, and they also need to fit, right? So this is also the other problem, that there isn't so much clearance here for some of these mounts. So maybe I need to, like, it could actually happen that I need to print a new one, because the one that I chose might not be working for some reason. This is actually the one I'm probably gonna use. So this sticks out to the left, and then the Beal touch goes in this direction. So we'll double check if that works. This would be nice. I think this combination isn't the one that I need. I think I printed a new one. Yeah, this should be the combination that we're gonna use. Hopefully, not 100% sure if this is gonna work, because the fan mount is still colliding here a bit. Could be a little of an issue, I'm not sure. Yeah, that's the part that I was a little bit afraid of, that I wouldn't have the right mount for the Beal touch. And that I probably need a longer one that is a little extended or something. This one looks right, but it's probably too short. What we can do in the meanwhile, we can put it in the printer in the key and then just shoot it out in a bunch of minutes. Why not do that? So, what's going on in the chat? Andy's answering a lot of questions. I just realized that there are 2 part cooling fans. Yeah, this is a quite powerful setup. It's probably overkill. For some, this might be, like, honestly, you can also go with a single blower and then have dual fan ducts. There is a version that has dual ducts with 1 fan. That's perfectly fine, right? If you don't need so much cooling, I think you're good with the simple solution with 1 fan. And you can also use the original fan. Honestly, you can just go and use the Ender 3 stock fan that is coming with the Ender 3 and just attach it to one of the blower solutions. And he just wrote in the chat, it's not recommended. The 4010 isn't very powerful, right? So there's not much cooling coming from that. But you can easily swap out the fans by just replacing the original one with a single blower fan, 40-50, what was that, 50-15, 50-20 even, there's bigger ones even. This is, but these don't run at 100%. You can probably go down 50%, 70%. Needs blinky lights around that. Yeah, that's probably right. So I am looking into the parts list because the Beal touch was the thing that I was kind of unsure. Would it fit or not? And I see that I probably need that mount here, but a bit longer, just a tiny bit longer. There is multiple versions of this available. So need to find the right one in a bit, and in the meanwhile you can just go and watch chat, discuss a little bit of the Andy. And of course I didn't download the files to this streaming computer, but it's gonna be easy. Just gonna do it in a second. How is everyone doing? What are you planning in terms of upgrading your printers? Is this inspiring? Are you feeling that you need to do it now? So let's download the latest version. By the way, if you're interested to implement this this HeroMe setup, Andy has a great Patreon page. I'm gonna post his Patreon link in the chat, so you can just check out what he has got on his Patreon. He is publishing these releases quite frequently, so he's always adding new hot ends, new printer, gantry adapters. Every time someone has something new coming up, people ping Andy, and he is quite quick with building these adapters, making it work. And the Patreon is there for supporting him, and he is also releasing the manual, so the detailed instruction manual on Patreon only. So if you are super good with modifying your printers, you might not need the manual, but honestly, I'm supporting him also because I think it's just the proper way and deserves this. And honestly, if you just need the latest version and you want to do it, you can also just support him for a month and then cancel that. But yeah, that's up to you. That's your decision in the end. Let's find the ABL mounts. Oh my goodness, there's so many wings. This is the thing. There's hundreds of things. BL touch, left mount, compact standard. So let me. Oh, this is probably not even the thing that I'm looking for. Wing. I'm looking for the wings. Left wing. Let me see. I'm looking for a left wing that is longer. So let me see. Medium left wing V2 STL. Let's have a look at the part. What's going on? So, I think this is exactly the thing that I printed. If I'm not wrong, this is pretty much the part that I printed. So, what is the compact left wing? This is probably a bit smaller then. So these are all the parts. So I'm trying to figure out which mount I need. Maybe left mount, Pure Touch left mount. Oh, this is not the thing that I'm looking for. I mean, there's two things. Either I need a new mount for the probe, or I need a longer wing. But I think I have already the bigger wing, the medium left wing. And probably I just printed the wrong mount, which is a little too close. So standard left mount. Why not go, like, why don't we print this one? I think this could work. Okay, so going back to the mount point, what I will do now is I will use this wing. Where is it? Here, we're gonna use the wing. So this is the wing where the BL Touch gets attached, and like just to get you what's going on, the BL Touch will be attached to the wing, and there's different wings, like which angle the BL Touch in different positions. Now we have not lots of clearance here behind the cooling fan and the gantry, so we need some wing that angles the BL Touch just a tiny bit. So I think this is the first thing. Probably just use it as it is, and then we can figure if we can print a smaller wing a shorter one. And the KD printer will be using to quickly do this. So let me quickly do that. Let me copy this to my local app. Here we go. This is the wrong one. Sorry. Copy that. Here we go. So, what do I want to do? So I think I will go with the Beer Touch left mount. Just try that out. And we throw it into the KD. Into KD print and have it printed. And let's see how fast we can print it on the KD. The KD is the new printer that I got last week, just a few days back. Actually, I think I did it on Friday. Or was it? Yeah, I think it was on Friday last week where we, not 100% sure. I think it was on Friday. I printed all the parts in PETG so far, but I'm switching to ASA. So the new parts that I'm printing now are going to be printed in black ASA. Yeah, zip file is organized in folders. I know. I've seen this. I think I figured that I have the right wing. So the wing should be the good one, but I have the wrong mount. So the mount is just a little too long, protruding through the inside. So I'm gonna try out the smaller one that is a little, where are we? Downloads, here we go. So we have ABL mounts, we have the BL Touch left mount. So this is the thing. We want to print it right now. Cement ASA, good. I think I'm just going to use the settings that I had. 110 degrees, 270. Okay, let's do this. Double check. Blah, 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 blah. And let's go. Send to the printer. This is probably not working again. Okay, so we've got to run to the printer. This is one thing about the KD that I don't understand, that you can upload the file to the printer, but then if you say print, it doesn't work. So probably it's just a bug that can be fixed. But I'm gonna start on the KD, so you can't see that because I'm in another room now. Okay, printer is starting. So how much time? What was the print time is 12 minutes. Okay, good. That's the good thing about having such a fast printer, is like you can throw it, and it's not even the highest speed. I think it's not the highest setting. It is probably, you can print faster. Let me see, what did we do in terms of the print speed? This printer. Print 200. Yeah, we could go to 300 millimeters easily, but I'm a little conservative with my settings. I want don't want to reduce the quality too much. The Bob has to go. Goodbye. I think today we're gonna do a little bit of a longer stream. Like you need to bear with me. Yeah, PETG is probably fine, Andy. It's. I think I had good experiences with PETG. Like all the parts are pretty sturdy. Like for example, this is the bigger mount for the BMG, which I used with the pancake motor. That's super stable. Like there's no problems with that. So all the parts are really sturdy, no question. It's totally fine. I think I'm gonna use, I forgot something actually, because I attached the wing, but I actually want to have, I also want to have this cable organizer. So what I will do, I will detach the wing, take a little bit of a longer screw, and then attach the cable organizer, the cable tower as it's called, and have both parts on. I will try to have both parts on the left side. I think we can stack them. Just need a longer screw now. Yeah, that's fine. So yeah, we're gonna stack these. Like this is the cable tower where we can like attach the cables with zip ties, and then I'm gonna just like stack that with the Beal touch. I hope this is working. Well, it seems to be working. Maybe that gives us the clearance. I don't know. Maybe we can now use the Beal touch. It goes protruding a little bit more out. Let's see, but I think it's still not working. Probably it's not going to work. I'm not sure. And this is also very close to, I think it's even, yeah, here the cable tower is touching my extruder, so it's pushing against the HextrudORT. On the other side, probably would be a better position for this, but I want to have my cables on the left-hand side, so I need some cable tower here, but that's pushing against the case or the outer edge of the HextrudORT. Maybe it's also better to have it on the right-hand side. If I'm thinking about it, here we have the big gear coming down, and if we have anything like protruding into the gears, not a good thing. So probably I have to rethink this and move it really to the other side just to be safe, because it's not good to have something so close to your extruder gear. There's a higher chance that something some cable might come into the gears, or it's just some zip tie end that might come in, and I don't like that. So let's stick with the original idea then, having the wing as the only part here, and then mounting the cable tower to the other side. Let's put it here. So this is the place where we can have the cable tower. So it's inverted. So then we can like fix all the cables here and then have them going over here. Still not, yeah, we could probably use a longer one, a longer cable tower, but at some point the cables have to go over this motor now. And then we have to wrap them, probably we have to wrap them right here, very close to the end, so that we have nothing dangling around. So need more screws here. Too short. So yeah, this is at least going to be somewhat helpful if we have cables coming from the hot end, from here, going up here, And then also these cables, we can attach them first here, so we have a clean solution. Having everything going around here, having it on one side and then going into the tube. That's what I'm going to do. But as I said, cable management is not our concern at the moment. That's going to be the last thing that I want to do. And he just released a new version, yeah, that's true. Yeah, the flexibility of PETG is it could be something that concerns you, and I'm with you. This could be something to look out for. But PETG is also not PETG, right? There's different PETGs, so you have to check your material and see whether the one that you are using is quite flexible. I found that the Prusament PETG is very stiff, right? So it's not very flexing. That's just a different material. It's still this, like, it's called PETG, but there is gonna be different ones, and you can use ASA, ABS, ABS plus, anything goes. So let's take a little break here. Anyways, what about, I'm just checking something here in the YouTube stream. Awesome. So in a moment, I will be going to check the KD print if it's working. So and then we hopefully have a part that works for our Beal touch. So gonna keep the cable management on that side, as I said. On this side, we'll have the Beal touch. So now since this is attached, I will double check. Yeah, this is definitely not working. It's too tight here. It's not gonna fit. So this one, I think we can throw that away. This is another one, but that also, I think that's an old version that's even not working. So you can also throw that away. Yeah, and the existing one is also not working. So I will disassemble this for now, so that we have our Beal touch, and we can attach it to the new mount as soon as it comes out of the kitty. Good, good, good. So my friends, I'm still confident that we are on a good way. I wasn't sure 100%, but since we can just print something in a few minutes, I think I'm gonna check on the kitty printer whether the part is coming out good. And taking a quick break, back in 1 minute. So we probably have an ad break by YouTube in a second. And that's why I'm gonna just quickly take a minute of a break. So see you in a second. Just walking over to the printer. So I don't know what YouTube is going to do now, because they have like probably inserted an ad. Let me know what happened in the meanwhile. So printer is done as far as I can see. Oh no, it's not. It's still going. So still have to wait for a bit. Come back later. So what happened on YouTube side? Nothing? Not sure. Did YouTube insert an ad, or did it not? I'm not sure. You never know. So I'm using a question here is from AK1CA. What pancake stepper motor are you using? This is an LDO NEMA 1420. So that's like 20 because it's 20 millimeter thick. It's I think it's 34 millimeter or 38 millimeter diameter. I don't know exactly, but I have put all the links to the parts that I'm using in the description of the stream. So if you look down in the stream and video description, you will find all the parts that I'm using. If you are wondering what that is. Are you planning to do input shaping on it? Might be one thing, because that is also something that's going to be easier now with the new base. There is 2 mounting points here at the bottom of the base where we can now attach an ADXL 123, I think it's called. There's a mount for the acceleration sensor, and then it can be used with Clipper to do the input shaping. So I don't know what happened now. That YouTube just told me they are inserting an ad at the moment. So I'm curious what's gonna happen to you guys. Let me know what happened. I'm just curious to see that, because that is something that they somewhat enabled now, and it's also helping the channel, of course, because we get some monetization to fund all the things that we're doing. But I never see it and didn't yet see it. So let me know if that worked, if something happened to you. Marlin can also do input shaping. Yeah, that's right. Marlin has input shaping. I have seen it. I've tested it also. I was wondering how it works, because there isn't an automation available yet. So you have to print out a part that has different input shaping settings for different heights. I've tried that and it somewhat worked. And then you need to write down the position, or you need to figure out at which position of the print, so at which print height the least amount of ringing visible, and then you can enter those numbers. You can recalculate the value with a formula and reinsert that new value into the slicer. Or you can also set it fixed in the firmware, so you can set these values on the slicer software or in the firmware in the menu of the printer. So it's working with G-code commands, and it should work to reduce ringing a little bit. I've seen these test prints on the Ender printer. I tried it. There was a little bit less ringing, honestly. Just a tiny bit. But on the other hand, to get to the point to see at least any ringing on this printer with this hot end, this setup here, you have to print super fast. So you have to crank up the printing speed and the acceleration a lot, right? To like acceleration above 2000 and printing speed at least 100 millimeter per second to get to a point where you really have significant ringing going on, that you can really distinguish those different levels of compensation, right? If you go slower, let's say you print at something like the default speed of 50 millimeters with 500 square millimeters per second acceleration, you won't see so much ringing going on because the printer is just going too slow. Okay, so we are going further. Our next thing I want to do here is figuring out from which side I can best run my cables for the hot end. And that is an interesting question, because what I see now, and I didn't realize this before I did it, this is always like you're finding out things after the fact. Always. Why should it be different? That the cable, running the cables to the hot end is rather difficult. Or at least there isn't much space left with these massive fan ducts. So let me double check what we have to do to get it working. So what I wanted to do is I wanted to come in with the cables just from the right hand side and then get it over here, but that we don't have much clearance, so we would have to bend the cable somewhat here. This is probably still going to work, but well, that wasn't thought through so well from my end. I wasn't really double checking that, so let me briefly take off this fan one more time. Here we go. So how can we get the cables in and still use this massive fan duct? Have to see if that is going to work, because the fan duct is really so close now to the hot end that this is going to come in from the side. So let's briefly insert it and I will show it to you. You'll see what I mean. So this cable is coming in here, and then like this, but our fan duct is gonna push it. I think it's still working. Yeah, it's still gonna work. So let's try it. So we have this little metal rod going in. Then the sensor cable comes. Here we go. And yeah, I think it's still gonna work. It's pushing a little bit against the cables, but it's still not critical. Okay, so let's use that. Thermal paste. Next thing to do here. So we have some thermal paste, and we're going to apply it to both the thermistor and the heater. Just need to get the protection cover off. Okay. So there's a little bit on this little scraper, and then we're just going to cover the heater with a thin layer. We're not overdoing this because it's gonna otherwise come out again. We have to clean the mess. So I want to have a thin layer around. And that looks pretty nice. So this is a high temperature, high, what's the value here? The conductivity is 13.4 watt per meter Kelvin. And that's one of the highest that you can find. So if you look for like what Bamboo, for example, is providing with their printers, that has a much lower conductivity value. So this is really the best that I could find. Quite expensive. EC360 Ruby thermal paste. Hopefully it's going to fulfill its job. We already have too much. So it's such a tiny layer that you need, unless you will see it coming out already when you insert the part into the tube here. So I think it's just good. Now we're doing the same with the little temperature sensor. I'm probably just using the rest here, which is giving us a little thin layer. So we have the best heat conduction. Should be good. Inserting it, and it fits in perfectly. That's so satisfying. Oh my goodness. Oh man. So what's going on in chat? My friends, what's going on? Are you doing good? You didn't see any ads. Well, that's good for you. That's bad for me. Good for you, bad for me. But I'm not gonna cry. Honestly, I don't care so much. So these cannot come out anymore. There is a little screw from the side that's just gonna hold the thing in place. Now this is done. We can reattach our fan mount. But again, the order of things is sometimes super important, more important than you might think. In this case, I just forgot to check that we have to do the thermistor and heater first, and then then attach the blower fan. So clean up a little bit here. Good. Let's get this done. So where's my hex driver? Here we go. So let's not lower it too much. Again, checking that we have clearance for the nozzle. And we are still pretty close to the surface with the cooling duct. That can be tricky. I think that's good. We still have some clearance. We can also double check using something that's flat. I don't care. Let's take this one. Nozzle tip. I think it's looking good from both ends. There is a millimeter or so, 2 millimeter of clearance. Yeah, that's probably good. Don't want to go lower. It's a bit too risky. So, attaching the backside. Good. Fan. So we want to run the cables organized way. Come in here. That's where it goes. So, who has questions? Sun Turtle Camper, please don't put ads on your streams. You earn nothing on ads. It just ruined the experience for the viewer. Thank you, God, for ad blocker. Yeah, yeah, good thing that you say that. I think that I personally also wouldn't want ads on streams. I'm personally fine to watch some ad before the stream, and then after when I want to watch the next video. But oh yeah, YouTube Premium is definitely one solution to get around watching any ads. So this is, I don't like this buck converter anymore. Honestly, I would probably want to have it in some other place very soon. But yeah, let's just go with it and test things out, because now the only thing that is missing is the beer touch. So we'll quickly go and look what the kitty is doing. It's still not done. I think it should be done by now, because the kitty is supposed to be printing a new Beal touch mount, and it's done. It's super hot still. Oh my goodness, 110 degrees build plate temperature. My goodness, don't touch it. Okay, let's get this thing off. So, here we go. The new mount just came out of the printer, this time in black, ASA. So let's see if it fits, if we have enough clearance, and that looks good. I think that should be working. So we can bring the Beal touch behind. Let's not throw things off the table now. So we can bring the Beal touch in this position here. I think it's actually this way around. So, is it? Let me see. What's the right orientation? I think it's, come on. It's this way. So it's gonna be in this position somewhat, holding the sensor, and there is just enough clearance here that it fits behind the blower fan. So let's use that. Yeah, the buck converter shouldn't be here. It's an ugly solution, honestly. I hated it in the moment when I did it, but I was lazy and thought about, okay, now it's working. Let's let's not touch it anymore. Let's just use the printer as it is, and then, yeah, this, you know how that is, right? So things are, as soon as things are working, you don't want to change things anymore if it's not really necessary, if you don't see the need. So same here. The printer was working fine with this ugly with the ugly solution, and that's why the ugly solution became the permanent solution. It's always the same, right? Has it ever been different? Honestly. Right. What's the buck converter for? Yeah, the fan, the front fan here is 12 volt and we're running 24 volt setup in this printer. That's why. It's just otherwise not working. Okay, so we have untangling the wires here. So this is the sensor. Let's put it in place. Good question. Yeah, I completely forgot one important thing about this part, which is of course, because I printed that last, I forgot the threaded inserts. So yeah, let's okay, this is one of the things now. This is another temporary solution. Let's keep it. Let's keep it. So normally I should have done threaded inserts in these 3 holes here, right? So because it's meant to be like that. There's supposed to be threaded inserts. They would come from the back, so we would have 3 coming in from the back. I didn't do that because that was one of the last parts, and we'll just use nuts and bolts. And it's probably going to become a permanent solution. Although it shouldn't be it should only be temporary. It's still not long enough. Even longer screw needed here. Next size. So let's just keep the cable in an organized way. We tangle them too much. It's difficult to get them back in order. Let me briefly get this. My goodness. I wanted to do the cable organization later. So, but we probably shouldn't mess it up too much. It's going to be super hard otherwise to fix it. Good. Well, let's try this screw. This is still too short. Even longer one. That's why I wanted the threaded inserts in the first place, but I forgot to do it. So finding the right screws in my box here. There we go. Keeping things organized. Okay. So I'm wondering if these are the longer versions or not. Those probably even longer than those. Oh yeah. My sorting box is really so full. Super hard to get this done at the moment. Let me see. These are the same ones, yeah. So they are supposed to be M316. What are you guys doing in the chat? Fans are not in series anymore. I did this on another printer. Actually, I did two 12-volt fans on the Ender 3 in series because I only had two. I had two 12-volt blower fans. Then I went to the Ender 3 Pro, so this printer, the Ender 3 V2 and the Ender 3 Pro, where I used 24-volt blower fans. I didn't have any issues with one or either one, right? So I didn't have any problems with the series of 12-volt blower fans. Works fine. So I can't say that this is not working. Like, just saying that you might be right that this could be causing some issues, but I didn't have any issues so far. So I can only speak for my experience that it worked fine with fans in series. But yeah, this might not be the best. Okay, so we have probably a working solution now. Good. So the way how this works is we can adjust the height of the sensor by moving it up and down. We need to double check now what is the good position. We need to move it up even further. A little too low now. We are too low with the sensor. We have to go up quite a bit actually. Much too low, honestly. So let's use the upper hole for this. Gets a little problematic there with the mount, but it should be still working. Let's see if we get in trouble for this. So moving up the sensor should be above the nozzle when it's retracted and below the nozzle when it's going down, so we can have still a bit of room to play. That should be fine. We could try it out in a second, hopefully. What's a little bit of a problem with this sensor mount is that it's probably not supposed to be holding it. Yeah, I think this is a temporary solution still. Probably have to replace it. So I have to replace the wing mount because that wing holding the front sensor mount should be higher. It's not meant to be holding the sensor higher than the actual wing. Now it's going above and it's, yeah, there's a little gap here. It's not the worst thing, but again, it's not perfect. So I should replace the wing with a higher one. What I will do now, we'll take the risk of turning on the printer because I want to see if we have anything wrongly connected or any issues with the electronics. Just double checking whether at least I can see things working a bit. No power cable plugged in. Fixed. Okay, so let's put power on. Good, the probe is working. That wasn't such a surprise. What I want to check is, so at least I can see on my display that the temperature sensor is reading something. What we can also do is try to heat up the nozzle. See if that works. Okay, so the fans are going. I probably have to replace this one. This is vibrating quite a lot. This one is good. They are also a little bit older now, so probably have to replace. Yeah, it's a little, there's too much vibration with this one. This is probably, the bearing is reaching end of life. Terrible noise, but these are not fresh fans, right? So the other thing is the front fan working? Yeah, it's working. So nozzle is heating up. I can see the temperature rising. So although we don't have the right temperature sensor configuration, it's a 100K sensor as the original one. So at least from the from that value, it should be the same, but I think it's just behaving a little different. So there might be in Marlin firmware for this specific sensor, there might be a different setting. I want to see whether we can at least bring the thing down, or at least we can at least test the motor movement. So let's see if the extruder is moving when we have it heated up. I don't know if you can see it, but I will try it. I will just try to move the extruder motor and see if that is working. Not really. So if it's not moving, then it's probably a cable problem. Could be some wiring issue. So what about Z-axis? Yeah, that's working. X-axis. Good. Y-axis seems to be working. Good. So what's working is temperature is working, temperature is rising. What we can do now, since we have the temperature already up, we can also raise it to 200. Let's go to 250 and tighten the nozzle, because that nozzle is still not tightened here, so it's just hand screwed in. But I will fix it now. Let me see if I have the right tool here. Hopefully, I'm not sure if this is the right diameter. Too big. Just need to get it from the workshop. So let's hope this is not going to blow up. Here we go. So either we use the right wrench, or we are lucky. Is this working? Well, it's too big. Yeah, this one is fixed. Good, so let's tighten that. Not too much. Good. Nozzle should be fixed now. ready to take some filament, but does the nozzle unscrew itself? It might be that it had unscrewed itself a tiny bit, but it should be fixed by now. Okay, so it's done. The only thing that isn't working is the motor direction, or turning the motor. Seems to be not working, but I've seen this already with another upgrade on another printer, that it didn't move because it wasn't connected in terms of, like, there was the polarity not right, cables weren't connected correctly, so we can fix that. So let's turn it off. So far, so good. So what worked is, well, we saw the sensor moving, so that should be, normally shouldn't be an issue, should be working. Heating up the nozzle worked. Temperature readout works. Fans are turning, although we need to swap out this one, is super noisy. Yeah, and we need to fix the motor direction. That's gonna be a little bit of a tricky thing, because I need to find out how the cables are working for this motor. Thing is, it wasn't documented, though. There wasn't no paperwork coming with the motor. It was just a package with the motor and nothing else. So I need to find some docs how it is connected. Probably need to fix the connector plug and just rewire it. So LDO NEMA 14. Let's see. Should be hopefully documented somewhere. Do we have some pinout? Just looking for it on AliExpress. And then we can compare it with the Creality mainboard. What is normally set there? So this is what I got from, where is the file? Here it is. This is what I got. Is there anything mentioned about the wiring? Here we go. Here we go. So a red, green, and yellow, blue. So I'm gonna have to check on the Creality pinout, because that might be slightly different. I think it is not going across. I think it's paired on each side. I'm not sure 100%. T427 stepper pinout. Normally we should find something about it. Not 100% sure. But I remember that the stepper motor pinout was documented somewhere. We can also just say pinout. because these are usually, I think there is some schema that I saw so long ago. Anyone can help just to figure this out for me. I'm just looking for some dock. Maybe we can find it here. I'm not sure. No, that's not right. Why is this always going in the wrong direction? Let's find, let's look for it. Creality 427, stepper motors, pinout. So red and green wires would go on the left 2 sides of the plug and the other 2 on the right side. Yeah, but the thing is, I think that's what it was. And I'm not 100% sure if that's correct, if they have wired it up this way. So I'm just looking to find some schemata to find if there's anything that's how it's documented. I think that it was documented. Is this the right? Maybe not really. We're getting closer, hopefully. What is this? But I think you could be right that it's paired like this, so that we have A and B not crossing, like A and A1 and A2 on the outer, and B in the middle, like it is with this motor, but it's pairs on each side. Let's see. Last, I think, is it here? Why is this not documented? Why is this not documented? This must be somewhere. And I remember that I had the same problem already, and I was funny. This is a picture of my own video here. Why is there no image anywhere anymore? I think I found it somehow. Maybe I used the wrong term. I can just try it out. I think we cannot break anything. Good. Okay, let's go and let's just go and rewire the cables just to try it out. I'm pretty sure that on my other printer, this very same problem, and I fixed it by moving those cables out. I have pairs on the outer side. So let's see. At least the motor is documented. That's at least something good. So unplugging the cable. So where's my image here? Red and green belong together. Currently, interesting enough, red and green, you can't see this from there. Oh goodness. I think we have a good amount of wiring work to do later to make this a clean setup. So on the plug, red and green are already on one side. Blue and yellow are on the other side. So they are already how they should be. Not sure. Maybe the cable, maybe that shows how it should be and it's not. So maybe just do it in the order on the picture and try that again, because with this one it doesn't work, so it's not moving. Let's take them out. I just grouping them in a different order as on the image. But who knows if the cable colors are correct? I mean, oh my goodness. This is something I really hate to do. And you know what? I have an idea. I have a second motor on my table, and I will just take it and try it first. Double check. Bringing that down. And that second motor, I don't know if it's the same wiring, but at least we can use it to check if it's, like if the extruder is, I don't know, blocked or the gears aren't moving for some reason, who knows why. So we can at least double check this. I'm quickly plugging that in. Let me see the cables. Oh, same order of cables. So that's good. Or bad. Let's see. I don't know. Let's start the printer again. This time on the side. So heating up again. Temperature, nozzle. I think we need at least 190 or something so that we can move the motors. So let's do that. So I have this second motor here, so I can at least easily check whether it's turning. Much easier than on the hot end. Multimeter in continuity mode or resistance mode. That's right. That would mean checking the cables of the motor, like to see where the pairs are, right? I can grab a multimeter to do that. The question is, how do we find out which, like, what are the pins on the main board? Because we don't, like, if we know the cables of the motor, we still have to figure the right pins on the main board. And honestly, what I can do, I have one way to do it. We can bring, I have the other motor from, like I have the original motor from Creality. We can measure that with the multimeter and then we can compare it. Because that has the original wiring. But anyways, I'm trying to move the extruder motor now just to see if it's moving at all. Not really. I mean, there's also no power on the motor. I can just turn it as if there is no, it's not getting any any power. That would mean, like, if, yeah, that's definitely not wired correctly. Okay, so let's imagine, oh, well, how many combinations are there? So let's figure this out. So red, green, and take the multimeter, bring the original motor so we can compare those wires. I think it's still on the other printer. It should be there. Where is it? Here we have the motor, so I think that should be good. Ah, this has 6 pins. Yeah, it has a different cable. Okay, so we need one of the original cables then. Yeah, I think anyways we can do it. So my friends, we're hopefully getting closer to solving this issue with the help of the chat. Peter, you can check by unplugging the EX motor. If we are sure that this is the same wiring, I mean, yeah, let's try this. This is the Z motor, so let's measure that. Take the multimeter. So here we go. Okay, so let's take the first two. Okay, the first two have 0 resistance. That means there should be a cable going through. Is this possible? And the second also. If I go cross, there's probably nothing. Ooh. That makes me thinking. If it's indeed... Okay, so it's indeed like the outer 2 pins on each side are the motor cables. Yeah, shoot him, Carmen. Use a big hammer. Okay, so what we know now is exactly that there is 2 pairs of cables, each on the outer sides of the connector. So let's check the LDO motor if it is wired in the same way. Come on. No or yes. Well, at least it seems so. That makes me thinking what could be the problem. This printer was working. The only thing that I can think of is that this stepper driver isn't working anymore, we can, I mean, we have another way to check this. We can just go and plug the motor into the Z motor, for example. Just plug it in here and see if that is moving. So, moving the axis, Z axis. Aha, okay, so the motor is turning. If we connect it to the Z axis, it's moving. Yeah, Peter. Motor is moving. Man, this is not good. It's not a good sign. That could mean that the stepper driver is broken. It's not good. I hope not. I really hope not. Because that would mean we would also have to swap out the main board. Which gonna definitely get cables. Are they going in? I mean, is this connector working properly? Maybe it's just not connecting right. It's not connecting properly. Let me push it a little bit while trying. Let me just push it and see if that changes anything. Maybe it's just a little wiggly. Nozzle temperature up. Come on. No, not that much. So maybe it's just the connector itself. Maybe that's broken, or it's not working that great. So I have some, let me see, where do I have it? I have some connector grease. We can use the connector grease, put some of that on the connectors just to have a little better connectivity. Let's see if that works. Let's see. Motion, move axis, Z axis. What is going on? Okay, I'm not Z axis. I don't want to move the Z axis, my friend. I want to move the extruder. Ah, come on. Hot and too cold. Yeah, proceed. Okay, it's moving now. I think this connector is somewhat... Maybe the connector... Yeah. Oh yeah, the connector is... There is some issue with the connectors. And it's also like I can plug it out very, very easily. So what I will do, I will put some connector grease on the plug. Use something like switch it off and use, we have nothing here. Let's use the hex driver. So I'll put some of the grease on the connector. And then I'll fix, use a little more. Let's also put some on the plug, even though it might come out. Just do the tip of the plug, just a tiny bit. Come on, not so much. Okay, so I'm going to plug it in again, and then we're going to fix it with some hot glue. I hope that this is enough to get a good connectivity. Let's see. Yeah, it could be that soldering joint, or it's really just too loose and it needs some grease. Let's see. Let's move the axis one more time. Gonna wiggle. Yes. Okay, so the extruder is the motor is moving. I'm gonna wiggle the motor a little. Let me move it a bunch more. So wiggle, it's not changing. I think it was just bad connection. So the grease seems to have fixed that problem. And yeah, it should work. At least for our test purposes, I hope it's enough to work with. So let's close this thing again. Put it on the table so we can at least try to extrude some filament and figure if the motor direction is correct. And then we'll have some other problems to fix. I mean, we're not really done yet. Goodness, this is such a mess. Fix it. We have to fix it very soon, I guess. Otherwise, we won't be able to print anything, honestly. We need to do the cable management very soon. So, okay, so what I want to do now is really quickly test extrusion. Let's keep it like that. Not waste more time. So we'll briefly try to extrude some filament, load some filament, and then see whether the motor is going in the right direction. We need to invert it, stuff like that. And then I'm starting to do some initial cable management. So we are wrapping the cables, at least starting from the hot end side, to make it a little cleaner. Still not happy with this buck converter, but yeah, that's how it is. Okay, one test we can do for now is homing. Let's home the printer. Oh. Seems that I see where the problem is. Interesting. The end stop switch. Yeah. So the end stop switch is here on the side, but our massive Beal Touch mount is somewhat preventing it from hitting the switch. Like it's just, yeah, it's just, I don't know how much is missing. 2 millimeters or something. So 2 millimeters are missing to hit the switch or to push it. It's actually touching it already, but it's not pushing it. So, are we up for another temporary solution? It's gonna... Oh my goodness. So, are we up for another temporary fix that is going to fix the problem with another ugly solution? I don't like that. I mean, thinking about actually moving the Beal Touch to the right hand side. Well. That's probably the thing to do here. Okay, so now we have fixed, at least we have fixed the extruder. Let's try the extruder now, and I have some idea how to fix this problem with the sensor here. We can probably just put something on the frame. Okay, so let's load filament. Change filament. Let's do the other thing. Motion. Move axis extruder. So we want to extrude into the extruder. 10 millimeter. Okay, that's going in the right direction. So that's at least moving correctly now. So I'm positive that we can load some filament. The only question is the steps correct? Do we need other step settings? See in a bit. So loads filament. Let's try that. So putting some random filament here. Loading that. So, printer is heating up. We can test at least the extrusion, whether it's coming out of the nozzle. Here you see the problem. This little switch here, we're not touching it because the beer touch mount is running into the frame right here before, just 2 millimeters before the metal frame here. The gantry can touch that switch. So I think only way to solve it for now is to have something attached to the gantry by, I don't know, something, gluing some plastic part that's 2 millimeters thick to that, which is another temporary solution. It's going to be a permanent solution over time. No, I'm kidding. Get a SKR board, yeah. I have one here. Indeed, I have one. I have the SKR3 Mini that I would love to insert filament and click. Okay, let's do that. Yes, I'm already doing it, my friend. So where's my filament sensor? Here. Come on, forget about it. We don't need it for now. Insert filament and click. So it is pulling the filament. That's already a good sign. I'm curious because we didn't test the full filament path yet, but that's going to happen right now. Is it extruding? Still loading. Purge more. I think we have to increase the purge length for this specific setup quite a bit. Now. Oh yeah, victory. It seems to be working. That's good. Okay, so that is working, and then we have some success. Extrusion is working. Motors are turning. Sensor seems to be working. I don't know, but it's at least, it looks like it's working, and it's still too high. Or too low, too low. It's not too high, it's too low. I just see it because I think when we fixed it, the nozzle was still not fully screwed in. So we bring it up even further now. Yeah, that looks much better. Okay, so last thing to fix. We need to find something that we can briefly glue to the frame so we can touch our X end stop switch. Okay, mission is to find something that we can use, where we can use some power tape to fix it. So first find the power tape. It's probably in the workshop. But we also need something to fix to the frame. Some random plastic piece. Yeah, we have so much garbage here, we can use that. Good. Found the tape. So now let's find something that we can glue or tape to the frame. I think I might have found something already. This looks great. So we have this little plastic piece. Gonna just tape it right here. So we have something that's gonna push our button just before I can print out a new BL Touch mount. Because that's the thing that I have to do now. I need to print a new BL Touch wing to fix this problem. So let's use the tape. Fix that in place. Something to push the tape. Okay. I have high hopes that this is a good solution, my friends. It's the temporary solution. Let's try it out. Let's try it out. So come on. No, I don't want to perch more, but it's still doing it. Ah, come on. So we have a few things to test now. We want to test homing. Let's see if that moves in the right direction. Oops. Oh yeah. Yeah. We're too far up now. So we should be homing now. Let's see. And then we have to do some cable management. And I hope the BL Touch is now in a good position, I guess. Yes, it seems so. Maybe it's still a little bit too low. But let's see. It's gonna touch quite far up. Yeah, it's pretty high, but yeah. Good, homing worked. Yeah, I think that's everything that we need to test so far. This is, it's such a good solution. The tape's gonna last forever. No, just kidding. So, what I will do now, honestly, I will do the cable management right now. Probably unloading the filament before that. Let's do that quickly. And then we do wrap the cables so that we have a clean setup. I'm thinking about how to fix this buck converter. Yeah, I think I have to do it. At some point I have to move it to the end of the cable that's inside of the electronics box. And I also have now a very, very tiny, like buck converter, like super tiny, that's still gonna work. This one is huge, right? This is massive. I mean, it's not heavy, but it's just too big. So, what does the chat do? Justice delivered. Stop spamming. How do you do that test of the purge? I do filament load, which is a function of Marlin, and I just say purge more. It loads the filament in, and then you can say purge more if you're not happy, if you didn't see it yet coming out of the nozzle. What's wrong with Nightbot? Maybe we have to. I can't check it at the moment. I can think that I can imagine that Nightbot has some weird spam settings. Honestly, I have had very conservative settings because I didn't want to be looking at the chat and fixing issues at all. So, but I can maybe turn it back a little bit. Honestly, can I make that purge test? Yeah. Good. The purge test is like, it is in that regard, it's not a purge test, it's a filament load function. So filament loading function is part of Marlin, and it's the M600, essentially the M600 command. Goodness, things are falling from the table. So we are doing the cable management. Just figuring where I'm gonna put this huge buck converter. But we'll start on this side first, and we'll do these two cables here. We're gonna come over there. So I think I'm gonna fix the buck converter right here for now, and then we're gonna move it. We're gonna move it away at some point. I'm gonna fix it here. Probably just gonna fix it right there with a zip tie, together with the other cables that are going into this cable tower. So we have everything here on the right hand side attached. I hate this thing, but it's, yeah, was one of the worst decisions that I had done, probably, on placing it there, but that's how it is for now. Okay, zip ties, my friends. Zip ties, zip ties, zip ties. Ah, come on, everything's falling down now. So, this little cable tower here has slots for zip ties, which is a nice feature. I'm going to, well, we have to find some way to hold this thing together so it's somewhat compact. Can it be done in a way that it doesn't get in anyone's way? Only way is probably this way. Somewhere down here. Good. It's terrible, but it works. So, to be fixed. Okay, good. Next. The Beal touch is also going to move to the other side at some point. That's probably not an issue. We can still wrap everything now and then change that later. So let's start here, wrapping the cables. Good. Put everything into this tube, and then we'll start bringing it. Other thing that concerns me, but Andy wants to fix that. He wants to make some kind of a longer or angled cable tower. that would make it possible to have everything attached, have everything attached to the left-hand side, angled by 45 degrees. I think that's something that I want. So, but we can also print that out once it's available and then move everything over. Anyways, we have to bring all the cables in this tube anyways, and that doesn't change anymore, right? So it will stay as it is, independently from the solution that we're going to have in the end. It will soon be time for the tube super glue, yeah? Mm-hmm. Either that or the hammer. If it's not working, we need the hammer, right? That's always the best solution. We smash everything with the hammer. That's gonna fix all of our issues at once. Oh my goodness. Honestly. So, on a good way, I'm bringing all the cables into the wrapping tube. So we have everything nicely and clean going down to the electronics box. So let's make a little turn here. Oh, filament. Yes. So, still going. So let's open this box again so we can finalize it. Okay. Only thing here is that these new heater cable and sensor cable are very long, much too long. So I'm not sure if I want to cut them or shorten. Probably just going to put them in a loop to get them. Yeah, didn't want to cut them. Could have done this, but I'm not sure if I'm going to use this on another printer. Maybe it's someday. And then we need the longer cables, and these. Honestly, the heater cable or the heater. What's that? Where is this going? Is this not? We forgot one. Forgot one cable, but that's the good thing about this wrap. We can always insert a missing cable later. So we do it now. So let's finish first. So this comes in here. Everything else goes in. So we are pretty much done already. I think we could push it a bit further even. So the cables are good, I would say. I think it's even a bit too long now, but yeah, let's bring it here. We have to get rid of the rest of this cable here. I'm not sure if I will keep it. It's just very, very long. And I'm not sure what's gonna happen if I'm gonna bring that together like this. If it's gonna break or something. If we have enough space here in the electronics box to keep it, or I'm going to keep it outside. Probably I'm going to keep it outside. I think that's the better solution. This is just so much cable left now. Yeah, let's have it here, outside of the box. So it's starting to look a little cleaner now. So zip ties. Here we go. One to hold this together. The good thing now is we have lots of clearance under the printer because of these additional feet. So no issue from that side. Okay, so last thing here. Yeah, stupid. Let's do it differently. Let's just bring those cables together first. It's better. Okay. What are you doing? You're laughing your ass off. Yeah, why? What's so funny, my friend? What's so funny? You see, that's what I like so much about the cable wrap. You can just have some cable inserted, that's done. So before I will fix anything now, I will just close the box. So I know at least that I have everything stored away. And we have enough clearance to get the cables out. And then move them into the right position. Fine so far. So, box cover. Where is it going? Here. In place. Number 2. And that's the difficult one, which is probably too short now. So I get a longer one. Probably need a longer one. Okay, so the box cover is in place. Cables are going up. Hopefully everything is good. So these are good. Let's close the printer down. So far so good. The sensor, filament sensor comes last. Normally it's just above the inlet, so it's sitting right here. Last thing is that we are going to close the end. Nothing can come out unintended. Our temporary solution is becoming the permanent. No, just kidding. For now, I think for testing, so just that we have something that we can use to print. That's my goal for today. I want to print something and I want to fix the, yeah, this is going to work. So we're going to fix this finally with a bigger zip tie. Well, we have so much work to do still because we need to clean up this whole situation with the Beal touch mount and this temporary X switch. I mean, that's going to be another evening, I guess, to print the replacement parts and to get it done. So let's bring this in position. Should be good for now. Let's bring it up to the very end, to the highest position, so we can see whether we have enough cable for that. So if you move up, you should still have some clearance. And we should have some cable left. Okay, so move to... Okay, let's see how high we can come. 220. Let's go for 220 for now. I'm doing this because I want to check whether we need to get more cable here through, pushing that into this left direction. But I think we should have enough cable. We can just see that in a moment. So, still a bit. Okay, so now the cable is getting stretched. Not enough here, so we'll probably need a bit more. So let's move it also to X to the right side. To the very end. So not more than this. Yeah, this is probably the thing. A little more couldn't hurt. That's why I want this 45-degree outlet here somewhere. Not sure where we can actually have it. Probably needs to be on the top element here that is holding the extruder motor. So I think that is something that Andy can provide, or we can remix the part. I want to have a 45-degree angled cable holder where I can zip tie my cables to. It's coming probably right up here and then angling a little bit to the left side, so I can fix it in this position as I had it on my previous build, because there the cable wasn't up here, it was really coming from there. So that alone is giving us a little more clearance, while we can like just route the cable different and we don't need longer cables for that. For now it is a bit too much stretched in my opinion, and it's gonna like move 235. I think it's the height is 233, so the printer should, I don't know how much we actually should have on this printer. So we still have some room. I mean, we are not yet at the upper end. Should I have some millimeters? 240, I think. Then we are pretty much stretched here. So I think we can still get a little bit of cable out of the box here. It's probably still a little bit of room, but it's not much left, honestly. Not much left. Yeah, pretty much stretched. So we would be really printing at 240 millimeter. This would be the very last position where I would say this is good, but this is already pretty much stretched out. Not really stretched out, but it's getting to get some tension. Right. So let's do the following. We will heat up to TLA temperature, and now our crazy loud fan comes on again. That's another thing that I want to replace. So you see there are still things to repair here, but maybe we can just make this printer do something today. Print something. Okay, so filament sensor, pushing in the filament, pushing it into the extruder. We will load filament first, or maybe we'll wait. No, we're gonna wait. We're gonna home the printer now, and I will do the Z calibration in a bit. Yeah. This fan is super loud. It is also really old. Terrible. Yeah. Also because it's not fixed here at the lower end, but that's what, because this part is broken off and I had to cut it off on the other builds. Maybe, you know what, until I get this replaced, another temporary permanent solution, use some tape. So, it's not as vibrating as much. Still vibrating, but yeah, this one is really bad. Do we have something on the SD card to print? Yeah, we'll check in a moment. I will do the configuration. Here, touch. No, where is it? Advanced settings. Probe offset Z Probe Wizard. Here we go. Z Probe Wizard. Also a Marlin feature. The Z Probe Wizard helps you to calibrate your probe in an easier way. So, just move it, bring it down. And I'm going to do this step by step now, smaller steps. Bring the nozzle down, so now we're touching. And we'll have some good resistance. I think that's good for the first layer. So the wizard is done. We can probably just store the settings now and try. Let's see if we have something on the. Do we have something on the SD card? Yeah, we have a first layer zigzag print. So we can try. Don't have a benchy there, but that's something we can fix in a second. I mean, the zigzag print is also nice because the zigzag print will tell exactly if there's any issue with the bed adhesion. On the other hand, I just realized that we have a very, very dirty surface because of all the stuff that we have been working on. So while this is heating up, just gonna clean the surface using some alcohol. So let's see if we can get this done. Super dirty. Grease, I don't know what this is. Oil, probably from the wheel replacement. Oh, what's happening? Oh yeah, we did not yet check. Why is it not? Oh, we didn't load filament. Yeah, we forgot about that. And we're still to close, I think. So what it also didn't do, it didn't do a bed leveling. For whatever reason, that didn't happen. Not sure why, honestly. So we can fix that in a bit. So let's first load the filament. But it also forgot to do the leveling completely. And one thing that I completely missed to do, but we can do it now, is replacing these old leveling springs with the rubber bumpers. That was also my plan for tonight. So what I'd say, let's just try an initial print. Yep, go for it. So can double check what stepper settings we also need, because probably different on this setup. Let's double check hex. What's happening, my friend? Are you having issues? Just having some issues to push the filament, obviously. It worked before. Why is it not working now? Okay, let me unload the filament. Why is it? Maybe I need. Let's cut the tip. Maybe the tip was not clean. Maybe too thick. Let's try again. And one more time. So, I hope this is working now. Yes, good. Okay. So, I'm now checking what steps we need for this specific extruder setup. But since we have been using the BMG already, I think it's not going to be different actually. But we'll see. We'll see in a second whether we have enough. So on this side of this, well, I think we're just going to do a bed leveling manually. Just kick it off that way. Do some, where is it? Motion, bed leveling, level bed. Let's do it. So, after that is done, so lots of temporary solutions for permanent problems. Now, honestly, I mean, this is an experimentation platform, I would say, for now. Although I see there is definitely some potential for improvements. The cable handling here, I don't like it. At the moment, I really don't like it, but I will fix it. That's actually the only thing that bothers me at the moment is the cables and that Beal touch positioning. But like overall, I think it's already, yeah, it's working quite well. So Beal touch, I think we can save the auto homing grid. So because for some reason this first layer print didn't have bed leveling enabled for whatever reason, but that's, yeah, if we do bed leveling beforehand, it doesn't matter anymore. Hopefully it's working now. And we can also do minor adjustments of the distance through the tuning menu. Probably gonna start very soon. Good. Not much missing in terms of the temperature, because we're already heated up. So, come on. Yeah, I mean, what we have to do is double check the correct thermistor settings, although it's still a 100K sensor. So it should be starting in a second. And we're printing a zigzag test pattern. So that's gonna be just for seeing, is the distance correct? Are we printing at the same distance in all points? Just fix this a bit better. Oh my goodness, it's definitely not boring. So what is happening? Something happening here at the nozzle, maybe it's too close, I'm not sure. Yeah. I would rather say under extruding. Yeah. Can go a little closer. Besides the fact that we are under extruding, I think it's still too far. Still too far away. That's the topic of setting the right steps for the extruder. To correct that, we'll have to do some test extraction. See whether we, yeah, I think we're getting closer to the right distance now. Yeah, still not perfect. So, almost there. Yeah, if you can scratch it off, I mean, it's not perfect, but going much closer doesn't make sense. I think we're gonna fix the problem of the steps first. Let's see what's set in the configuration, advanced settings. What is here? Filament. Right. So not sure if this is available from the print menu, stopping the print. So from that perspective, I think we're good. We're printing. Distance is okay. I would say sticking well enough. Still, I have my doubts about the amount of extrusion that we have, and we should double check the stepper settings. Advanced settings. Steps per millimeter. For ease. So we are on 418. I think I've seen that is not enough. We can also find it out ourselves by just measuring it out. Accept. Interesting enough, BMG has nothing on their homepage about the steps per millimeter for their BMG internal set. But it's not so complicated. So I have done this already multiple times. So we're gonna move it up a little bit. Let's say 100. So let's heat up to PLA temperature again. And then we'll just extrude a fixed amount of filament and see how much actually comes out or how much actually gets transported. Just need some pen, watertight ideally. I'm not sure if we have some here. Yeah, grab one. Well, let's It's too thick. There we go. Okay, so I'm just gonna mark my filament right here where it goes in, and then where's my, but I got nothing here that I need. Simple tools are missing here. My goodness. Okay, so we're gonna do in extruder calibration now. I am marking the filament, and probably should do that without the filament sensor. It's just simply in the way. So there is a calibration sheet that I'm usually using. Just bring it up on screen for you. That is, where is it? It's a very good question. Where I have it. Here we go. Please open it up. So, there it is. So we're just gonna use the existing 400, I think it's 418. 418 is the value that we are currently having in the menu. This. So unloading filament, loading, without the sensor. Okay, so when it stops, I'm gonna mark it 120 millimeter above the throat. Then we're gonna extrude exactly 100 millimeters. Normally that's enough. And then we measure how much is left. So let's do this. Still moving. And then the new E-step value is being calculated here. So we can measure what has actually been transported. It's still moving. So we're good now. So we're like easy calculation, just measure. Ideally go to 120 or something. This we have a little bit more slack here. So mark it here at 12. So now moving it to, so I'm moving the extruder 100 millimeters exactly. So I'm waiting. And when it has done the 100 millimeter extraction, So I've marked the filament right here above at 120 millimeters above the throat. And then again, we measure what's left, right? So then we're gonna calculate how much has actually been moving in. Still extruding. So the chat is pretty quiet. There's only still 18 people watching. I think a lot of you have gone to bed, or I mean, we still have 80 people watching. That's good. It's a pretty long stream today, but it's also pretty chill, I would say, because we just want to get this thing fixed. Okay, so we now officially extracted 100 millimeter, and now we can measure how much is actually left over, and you can see there's quite a lot still left. So exactly 6.1 centimeters, so 61 millimeter are left here, whereas it should be only 20. So how much has been extracted? 59. So we actually did 59 millimeters. So we're gonna put that into the calculation. And stepper setting should be 708.47. That's what it should be. 708 steps per millimeter. So going back to the printer, setting that into the configuration now. Say, okay, gonna say it's not 418, but it's gonna be 708.4. And then we're gonna do the same thing again. And see if it's fixed. A bit tedious to do this on the display, but yeah. I have no USB cable attached to the printer at the moment. I would normally do this with Pronterface, but yeah, we can already there. 708.4 or 5. 708.5. Okay. Store the settings. And let's go again. Okay, so I will be measuring again. 120 above the throat. So we're going to measure where this is. This is exactly here, up here. Mark the filament one more time. Get it as straight as possible. Okay. And let's extrude 100 again. Yeah, it's already moving quite a lot faster, which should be the case. And now we should exactly have 20 millimeters left when we're done. So we can measure if that's correct. And I think we're good. I think we're moving in the right direction with this build. Okay, so how much is left? Should be 20 millimeters. It's exactly 20 millimeters oil left. So we are good. Extrusion amount is fixed. Now let's do the test grid one more time. Yes. I think we're good. I think we're going to be having a printer that is working. "20 people still watching. My goodness. So, anyone who joined late, you missed everything. No, I'm serious. You missed the HeroMe 7 build on this printer, but we're in the last stages of testing the setup. It's not really clean yet. We have to do some different cable management very soon, but for now, we got it working. The extruder is calibrated, and now the printer is going to print a test pattern. So we see whether we have a working setup. So let me bring that over here. Okay, so I see it's going to start in the second, and I guess we have to adjust the distance a bit. Not sure if we are now too close. I think well, it's actually good. It's actually not bad. So I see. It's thinking how we had one thing that we missed, of course, after our little calibration is to reinsert the filament into the sensor. But that can be fixed. Now we are also correctly using the filament sensor. I had to remove it because it was just in the way of measuring the length here. Purge, yes, my friend, do it. Do it. Now the purge is actually too much. Okay, continue. So we're starting to print the test pattern. And I'm gonna test whether it still sticks well to the bed. So I want to heat up to 60. But I think we can come a little closer even. So this looks quite good, sticking quite well. I mean, can still scratch it off, but that's fine. And probably have to clean the surface one more time to get rid of any grease, oil that we had. But I think for now, this looks good. It's not easy to scratch it off anymore. So printing the test pattern works. Last thing to do is maybe to do a final test print and then try to print faster. But I'm pretty happy today because we managed to get this thing working. And it's printing again. And hopefully after some cleanup work this week, printing out some other mounts for the BioTouch, getting some other cable for the fan, replacing that buck converter. I mean, after doing all of these little things, I guess that we will have a pretty amazing printer. I'm gonna post some updates on that this week, so you see whether it's really true and how good it is working. But for now, the test pattern looks good, and it's also really very consistent. Here it was a little, we had to adjust, but here looks pretty good. So, how are you doing in the chat? Still there? Are you already sleeping? Are you still there? 19 people are still watching. Are you still awake? Or are you just hypnotized by the test pattern? Okay, so I think most of you already faded out. I will personally say I like this work today a lot. I learned quite a bit already. Still quite some way to go. And we'll probably talk about this once I've tested it thoroughly and made the final adjustments and the cable, the wire work. So we'll see this in the final shape very soon. I'd say with that, I'm gonna end this stream here. It's pretty late in Germany now. It's 1:45 in the night, so almost 1 o'clock in the morning. And that's why I'm just pretty tired now. So still trying to troubleshoot the damn end of 3S1 Pro. Oh my goodness. I wish you good luck with that, Sam, Sun Turtle Camper. I'm going to end it now, and I am happy with the results so far. I think we have a pretty well working printer now. Pretty confident that I can get it even better after fixing a few small things as usual. So see you back this week, and wish you a good night. Wish you a good night. Bye bye.